So another way to determine how fast something is going is to talk about its velocity. And velocity, while similar to speed, is slightly different. Now, for these two situations, if we wanted to calculate velocity, we'd actually want to calculate not distance, or not measure distance, but measure displacement. Now, in this case, with the two cars moving across the sidewalk, the distance and the displacement was the same. They were moving in one direction, and they moved a meter, and they were displaced a meter. So what we could do to make these speeds velocities is just add in one more thing, and that is the direction. A velocity always tells you the direction. So if I added in that these were going 0.12 meters per second south and 0.41 meters per second south, we now have velocities and not speeds. But just because that was easy this time doesn't mean that always will our distance and our displacement be the same thing. Let's look at an example of that. All right, so an example where displacement and distance are not the same would be if, let's say I'm driving my car and I drive 3 miles one direction and then turn around and drive 2 miles back the next direction. If I were to look at this situation, my distance is, I actually drove 5 miles. I drove 3 miles one way, 2 miles back. So I would have 5 miles for my distance. But my displacement is a change in location. So starting from my starting point to where I ended is only a change of 1 mile. So my displacement is 1 mile, but I should probably also say which direction. Now I didn't give you a direction here, so let's just say that this is east this way and west this way. So my displacement is 1 mile east. Now, how does that factor in when you start doing your calculations? Well, if we're looking at speed, we're going to use this distance number and time, whatever our time would be. And in velocity, we're going to use our velocity number, or our displacement number of 1. So let's say that this whole trip took me 10 minutes. Let's just say that's our time. So for our speed, we're going to take our distance, and we'll do 5 divided by 10, which equals 0.5, okay, and that would be 0.5 miles per minute. Now, a little trick would be if I wanted to know the speed in miles per hour, I'd have to multiply that by 60, which would give me 30 miles per hour. Now, on the other hand, if I'm looking at velocity, velocity is your displacement divided by time, and my displacement is only 1. So if I do 1 mile divided by 10 minutes, that equals 0.1 mile per minute, which if I multiply that by 60 to get miles per hour, that's only 6 miles per hour. But it's not a velocity until I add a direction, so I need to make sure that I get my 1 mile that I was going east. This would be 6 miles per hour east. And you can see that these two things have very different uses here. A speed would be much more useful for talking about distance you travel in a car. Velocity is more of a useful term when you're talking vectors. One last thing I forgot to mention. What happens if you go 3 miles one way and 3 miles back the other way? Your distance is going to be 6 miles, but your displacement is going to be 0, which means that your velocity will also be 0, because 0 divided by however long it takes you is just going to be 0 velocity. And that's where this can get a little confusing, so be careful when you're talking about distance and displacement, which one is more useful. When we're talking speed, we're going to probably be using distance more often than anything else. Okay, don't forget to check Google Classroom for the rest of your assignments. Big thank you to my amazing assistants, Drew and Callie. And if you like what you saw, don't forget to check out Mr. Brown's science videos and smash that like and subscribe buttons. And peace.